Hi, this is Dr. Eddie Morgan at Clovis East High School, ready to help you with your homework. Today we'll be looking at worksheet 4.6a. Remember that the homework help has problems that mirror the problems on your actual homework. So if you have trouble with one particular problem, fast forward to that problem and we should be able to help you out. Problem 1 says, what is the graph of the system below? So we're going to graph each line and find the area. Remember, each one's going to cut the section into two parts, and then we'll find the part that's common to both of them. So let's start with the first one here. We have y is greater than 2x minus 3. So the boundary line for this one is y equals 2x minus 3. Notice the slope is 2. And the y-intercept is b. So I can come over here to mean minus 3. So b is minus 3, so come down to 3. And then it goes up 2 over 1. This is 2 over 1, so up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And we can even go backwards. Now we notice that it's a greater than, so that implies dotted line, and we're going to shade above. So I mark my line dotted here. And we're going to dot, and we're going to shade above. What I'm going to do, a little technique we learned from Mr. McClendon, is since we're shading above, I'm going to put a plus on that side and a plus on that side, telling me I want to shade everything above. All right. If this were one problem, I would come in here and I would shade the whole thing right now, like, I would shade the whole thing like this to say, all right, that's what we're doing. But since we have a system, I'm not going to do all that. I'm going to do this because I think it's easier to do when you're graphing it. So now we have the next equation is 2y minus x is less than or equal to 4. Now notice it's not in our form that we like to graph it, the slope-intercept form. So what we're going to do is let's get into that. So we'll add x to both sides, and we get 2y is less than or equal to x plus 4, and then we're going to divide by 2 to undo that. Now notice we're dividing by a positive number, so our sign doesn't change. So we end it with y is less than or equal to 1/2 x plus 2. So once again, now we can see there's our slope, 1/2. There's our y-intercept, 2. So let's graph that. We're going to graph that one in blue. So I go up 2, and then my slope is 1/2. So it's up 1 over 2, up 1 over 2, and then back this way, of course, again. Now notice this time, less than or equal to means it's going to be a solid line because it has the equal part, and we're going to graph below. Okay? So let's graph the solid line first. And we want to graph below. Okay, so I'm going to put a plus sign below the line. And now, normally again, we would shade all the bottom area. But to get the system, I want to know where do I have a plus and a plus. Notice in this section up here, I have a plus red, but not a blue. In this section up here, there's not any. And in this section down here, I have the blue. It works with the blue, but not the red. The only place it works here is in this section here. Okay, so this would be our solution, the line plus everything in that solution. So let's just graph that, and we would end up graphing in here. We would shade in this area here. And that would be our solution. Okay. Notice on this side it's dotted, but on the other side it is solid. Okay. So anything in the yellow and on the blue line would be our solution. Number 2 asks us to do it in reverse. Look at the diagram and tell them what is the system. So let's start with what appears to be kind of the red one. And I notice, first of all, the red one intercepts the y-axis here at -2. So for the red one, I have a b equals minus 2. And my slope, if I look at it here, my slope goes over 1 and down 1. So I have negative 1, positive 1. So my slope is going to be negative 1 over 1 or negative 1. So my boundary line here is y equals minus x minus 2. Now notice that I have a dotted line and the shade is below. So dotted below implies that my inequality sign is going to be less than, not less than equal. So my first equation is y is less than minus x minus 2. So that's the first one. Now let's take a look at the blue one. The blue one intercepts the y-axis up here at 1, 2, 3. So for the blue one, b equals 3. The slope, you notice here, if I look at right here, it goes up 3 and over 1. So the slope is 3 over 1 or simply 3. Now, so my boundary line here is y equals 3x plus 3. But if I look at my line, it's solid, and I'm graphing above the line. So that implies that my inequality sign is going to be greater than or equal. So this equation is y is greater than or equal to 3x plus 3. And there's our two equations. That's the system of inequalities right there. Problem 3 says that cherries cost $3 a pound, grapes cost $1.50 a pound. You can spend, the limitation is though, you can only spend $9 on fruit and you need to buy at least 3 pounds. So let's define some variables first. I'm going to let x be the amount of the cherries, how many pounds of cherries I buy, and y is going to be the grapes, the pounds of grapes. Okay, so what's my cost? First of all, my cost is, for every pound of cherries is $3, so that's going to be 3x plus and 1.5 times y. Grapes are $1.50, and it can be no more than $9. So no more than means it can be $9, but it can't be more than that. So it has to be less than $9 or equal to $9. So we get less than or equal to $9. All right. Now the other side of it is I need 3 pounds together. So that means x plus y has to be at least. Now at least means that's the least I can have, but I can have more. So it has to be greater than or equal to 3 pounds. So there's my system of equations. So let's break it down to graph it. So if I take the first one here, if I take the cost equation, I have 3x plus 1.5y less than or equal to 9. Now this one I happen to look and see that the 9 can be divided by each of these. So let's do the x-intercept and y-intercept. So my x-intercept, let y be 0, then 3x equals 9, and x therefore equals 3. So I'm looking for my boundary line here. And so 1, 2, 3, there's where that's going to intercept. And on the y-intercept, it's going to be 1.5y equals 9. If we divide by 1.5, we find out that y equals 6. So it's going to be 1, 2, 3, 4, 5, 6. Now, in this case, I have a less than or equal, which implies that it's going to be a solid line and it's going to be below. Okay, so let's draw our solid line here. And we know it's going to be below. So I'm going to put that there. Shade in later which part matches. And now let's look at the pounds. And in the pounds, we have x plus y equals 3. Again, if I use the intercept, x-intercept is just going to be x equals 3. And the y-intercept is going to be y equals 3. So it crosses here 1, 2, 3, and goes there. Now in this case, I have this is less than, greater than or equal. So greater than and equal implies a solid line again, but this time above. Okay, so I can draw my solid line, and I'm going to put above. All right. So in this case, if I were to continue on down here, they would cross. But notice the area that is where they're together is above the blue line and below the red line. And so in this case, our solution is going to be right here in the middle. And that's the area. Now you notice if I were to continue these lines, this line would go here, and this line would actually come above it here, something like that. So it's only in this area here, and once again, this area here, we ignore this area because that would be minus number of pounds. Likewise down here, this would be minus pounds of our grapes and cherries. So in this case here, this is our solution here. Notice that X, to graph it properly, I need to note that this is the cherries down here, and this is the grapes up here. And so there's our graph. Anything that's either on the red line or the blue line or in between them there would be a solution that I could use that would give me, keep me under $9, but $3 or more in fruit, 3 pounds or more. Question 4 asks, how can you determine whether an ordered pair, remember an ordered pair simply means I have an X and a Y, is a solution to a system of linear equalities? Well, you do it the same way that you would do to solve if it was a solution for just an inequality. What you do is you substitute the ordered pair, but this time instead of going into just one equation, you do it into each inequality in the system, and then solve, and then, well, actually simplify, and see if you get true statements. To be a solution to the system, you need to get a true statement for each time you plug it into each inequality in the system. If one of them is true and the other is false, then it is not a system to the solution. It's only a system to one of the inequalities. 5 asks us to consider, suppose you're graphing a system of 2 linear inequalities and the boundary lines are parallel. In other words, I have one line that looks like this, and I have another line that looks like this. The question is, does that mean that there's no solution? Remember that when we were dealing with equations, there would be no solution because they would never intercept. In this case, it's not always the same. Now, it is true, if the blue one was a less than, and I was underneath here, and the red one was above, then yes, that would be no solution. But consider this, however. Consider instead that the red went below and the blue went above. Then you would have a solution because you would have the area in between would be the solution. Okay? So parallel lines, unlike in equations, doesn't mean no solution. And so, but if they happen to overlap this way, then you would indeed have a solution. Question 6 says, how is finding the solution of inequalities different from finding the system of equations? Well, one of the areas that they're different is that when you solve for a system of equations, you're solving for one point. That is the point of intersection. However, if you're solving for a system of inequalities, you're solving for a region. Part of the plane, coordinate plane. And that's very simple, you may understand. If I'm solving for an equation, I'm looking for where do these two cross, that's my intersection. However, if these were inequalities, then what I might be finding is different, is I might be finding I'm looking for this area here, which solves them both. So we have an area versus a point. Now, how are they the same? In both cases, when you graph them, in both cases, how they're same, you graph lines. For the equation, you're graphing the actual line. But for the inequalities, you're graphing those boundary lines. And that's pretty much the same process. Although with the boundary lines, you have to check, is it going to be solid? Does it have the equal part of it, less than or equal, greater than or equal, or is it dotted because it doesn't? All right, hope that helped tonight.